So hi everyone, my name is Majid. I'm a PhD candidate at the University of Toronto, working with Professor Terry Grossman. And today I'll be presenting a paper about improving users' ability to verify and control when they're using AI to do data analysis. This project was partially done in my internship at Microsoft Research with my amazing supervisor, Jack Williams. And yes, I'm currently in Toronto, and thanks for bearing with all the difficulties of this remote presentation. So at a high level, data analysis tasks often involve handling large data sets, writing complex code, applying domain expertise, and working with unwritten assumptions, which makes the process really challenging. In fact, data analysts describe the need to have a conversation with data to understand it. And now LLMs are enabling us to achieve that. So by having access to a summary of the dataset and a task description, the LLM can reason about how it's going to solve the task and then generate a code for it, which can then be sent to a code interpreter agent for execution and displaying the results. This is done with chain of thought prompting and React prompting techniques that have currently become widely popular. And currently, the most common interaction method with LLMs for data analysis is a turn-based conversational modality in which the user has to write follow-up messages and queries to steer the AI at each point. Now, let's see a quick example of such conversational interaction in action. Let's say we have a data set of anime series, and we're interested in their themes and tags. Particularly, we want to know what is the most common tag associated with each theme. For that, we can use a tool like ChatGPT's data analysis, which allows us to upload the data set and write the data analysis query. Since the AI does not know about the structure and contents of the data set, its reasoning process makes it generate a code that displays a summary of the data set. And then that'll be executed by the agent to run the code, and the output is then fed back to the AI to determine how it's going to solve the problem. The LLM then interprets the summary of the dataset and will generate a code to solve the user's task. And then lastly, the code is executed and the final response is displayed to the user. However, there is a problem. Here, in this solution, some themes or tags start with an uppercase and some with a lowercase, and we need to fix this. And one thing that we could do is, so what I'm currently going to do is just simply let the AI know about this new assumption that without even telling the AI what or how to do it. So just, there are different casings, that's it, and handle it yourself. The AI is then able to use this assumption to retry solving the task, but this time after making every tag and theme lowercase. You can see how this can become more challenging as the errors and issues become more and more subtle, which is actually the case in many data analysis scenarios. So to better understand these challenges that users encounter when doing data analysis with a conversational AI tool, we conducted a formative study. We recruited 15 participants, designed 4 data analysis tasks, each assigned to one participant, and they were asked to work on these tasks and think aloud for 60 minutes using ChatGPT with a data analysis plugin. Our results show that the first challenge that participants had was that they were overwhelmed by the long responses and the conversation history. So to address that, we wanted to help users focus on smaller information chunks at each time. Our first design goal was to prevent the AI from autonomously solving the entire task in one go by adding multiple intervention points and progressively revealing the response. The second challenge that participants faced was that they had to spend a lot of time understanding why the AI has generated that code. They had to manually infer the AI's assumptions. And again, to address this, we made the AI to explicitly generate and display these assumptions that the AI is making, and made them editable as part of each intervention point. And then the third challenge that participants faced was that they heavily asked follow-up queries that were unrelated to the main task, like code explanation, data exploration, and output verification within the main conversation thread. So it basically just cluttered their main thread with the AI. And to address this, our third design goal was to assist users to run side queries without cluttering the main conversation. So to develop a system that would address these design goals, the AI, at the core of this, the AI should decompose the task. However, how should this decomposition be done is an important question. So we identified three important design trade-offs within the design space of addressing our goals. First, how many intervention points should the AI create, and at what levels? Then, how much information to display at each intervention point, and how structured should the displayed information be? Therefore, we built two systems based on these design goals that each address different levels of the design space. The phase-wise system decomposed the task into different abstraction levels from high to low, while the stepwise system decomposed the task into sub-goals of the task until it was finished. Both systems started with a simple input dataset and query, and the system automatically created a comprehensive summary of the dataset for the LLM that provided textual information about each column. Now, let's talk about the phase-wise system. It decomposes the task into three abstraction phases: input and output assumptions, execution plan, and code and output. First, the AI retrieves all the relevant columns in the dataset and displays the assumptions related to each column next to it. And everything is editable in a structured way at this point, including the editing or adding new assumptions or adding and removing relevant columns to the task. Users can even inspect each column for more details, and once they're satisfied with things, they can move on to generate the next phase, the execution plan, which is a natural language plan of what the AI wants to do. Again, users can edit, move, select from the optional steps in the execution plan, and then once they're satisfied, they can go to the next phase, which is basically the code and its execution output. At this point, the code is editable, and if the user is not satisfied with things, they can either go and directly edit the code or use other things, or go to the previous steps and phases to make edits. Now, let's look at the stepwise system. The task was decomposed into multiple sub-goals instead of the abstraction levels that we saw in the phase-wise system. And it solves the problem one step at a time until the task is finished. And each step has two components: assumptions and actions, as well as corresponding code and output. So at first, it simply reads the data set, and the user can just inspect any intermediate variables, but then it generates the initial set of assumptions for the second sub-goal. And these assumptions are formatted to show the assumption and its corresponding action in natural language, allowing users to edit them directly. And when they're happy with the assumptions, the AI generates the next step, the corresponding code, and its execution output. And this process will continue until task requirements are satisfied. We also developed two features to allow users to perform silo operations during the data analysis process. In both systems, users can also run side queries to perform data exploration on the side without derailing the main conversation thread. These are natural language queries that are executed and displayed on the side of the user interface. They can also select parts of the code to either ask for explanation, modify the code, just using a natural language query. Now, to evaluate the effectiveness of our system compared to a baseline, we also developed a conversational baseline system, which basically did not have any intervention points, and the only method for steering was to ask follow-up queries. For evaluation, we ran a within-subject study with 18 participants in which they worked on 6 data analysis tasks. And the interesting thing about our study was that the tasks were designed so that the AI would produce incorrect responses without user involvement. And each task was injected with exactly 2 issues. Therefore, it required users to verify the output and steer it along the process. And participants were asked to think aloud, and at the end of each of the 3 systems, they were asked to fill out a short questionnaire about and would like to scale questions about their experience. And for the sake of time, I'm just going to go over some of the high-level results, and please refer to the paper for more details about our results. But in terms of performance results, like verification accuracy, time and task, and task success rate, all three systems performed similarly, with no statistical significance. But in terms of perceivability, both stepwise and phase-wise were perceived significantly better in terms of how easy it was to verify the output, and how easy was it to intervene and fix whenever it was doing something wrong, and the user's sense of control over the AI's process. Almost all participants appreciated the ability to directly edit the AI's assumptions and aligning the system's operations with their expectations. This is a code that I really love from our study with a participant that says, I could add any assumptions that I had in mind and make it the AI's assumption. Participants found that when the assumptions were editable, like the stepwise or the phase-wise system, it made them more cognitively engaged, more critical towards the assumptions, and it was better than prompt engineering or asking follow-up questions. But when the assumptions were not editable, they actually tended to accept them without even questioning the assumptions, and it was a source of frustration and lack of control. Similarly, with more structure, like phase-wise system, users found that they can have fine-grained control over the AI's process, and it helped them with finding information easily, but it also was a source of information overload. But when things were less structured, it was more difficult for them to make targeted edits. Additionally, participants found several benefits with the stepwise system, such as improving their confidence, as they were not scared of making edits, and they were able to think about the process and verify each step along the way. And it was also more similar to their own approach of analysis. Interestingly, there were several participants that liked the baseline, the conversational AI, for some situations. Particularly, they mentioned that it required less cognitive effort and that they could create, and it has an easier mental model of the process. While both systems were preferred over the conversational baseline, at a high level, our results show that the phase-wise system let significantly more information overload, while the stepwise system was the most balanced and effective one. In terms of, so our design exploration and the results from our study guide the future of AI-assisted data analysis tools. We found three important design implications about how to build things. First, how many steering points should a system like this have, and what types of steering support should we provide, and what should the steering modality be? In terms of the number of steering points, if it's with less steering points, users can get to the final output much quickly, but it demands a bit more cognitive effort. And with more steering points, they will gain more confidence, sense of control, but it might lead to premature decisions. And in terms of steering support, we've included side queries or displaying assumptions and other interactive components, and this creates a genuine collaboration method with the user and the AI. And then lastly, in terms of steering modality, we found that with a freeform, with more structured editing, users gain fine-grained control with less responsibility, but with more freeform editing, it reduces their cognitive load. They can become a bit more self-critical, and but it also requires prompt engineering. Okay. And with that, I would like to thank you and take any questions.